Right, hello ladies and gentlemen and welcome to today's video. And today we are having a slightly different change of flavour and we are going to be looking at this MacBook Air. Now this particular MacBook Air is an A1466. It is covered in this nice little plastic blue protective case. As I say, so an A1466 with an 820-3437B motherboard in it. Now by my calculations I believe that puts it in around the mid 2013 category. And this particular MacBook comes to us with no power. So if we open the lid, and I believe the battery is charged, and we try to power it on, you'll notice we get absolutely nothing. No lights, no backlight, no screen, no nothing at all. If we plug our charger in, then we should see, if I just kill the light there, and just bring you down for a moment, you should see that we do indeed have an orange light on our charger. But again, we have absolutely no power at all, so I'm just going to put you back in the tripod for now. So please do bear with me today, boys and girls, because I'm working in my new environment for the first time, so things have been jerry-rigged up a little bit. I've not quite got enough power sockets where I am, so it's a bit of a mess, but what can you do? So hopefully within a couple of weeks we'll be cooking on gas in here, but for now. Anyway, so as I say, this MacBook Air, we have an orange light on the charger, but our power is completely dead. So we are going to look into seeing what we can do with this. Now, this particular MacBook Air has a backstory, don't they all? And essentially, this was brought to me by my mate, who is an electronics repair guy himself, but he doesn't do the soldering side of stuff anymore. In fact, he has a friend where this actually came from. And my friend's friend has an electronics repair shop, specialising in laptops and computers. However, he doesn't do component level stuff. He only does sort of like part swapping and things like that. He's not a component level guy. So essentially, what happened is he had a customer walk into his shop, and apparently this had some water damage at some point, but it's been working fine. However, the customer sort of noticed an issue with Wi-Fi, so he went to go look at the Wi-Fi, thinking he knew what it was. Popped the Wi-Fi card out, but he didn't notice that the machine was left on. It was actually in standby. And apparently, at some point, either somebody called his phone or somebody walked into the shop whilst he was actually removing the Wi-Fi card. He turned his back for 5 minutes, came back and put the thing back together, and of course it's dead as a doornail. So he suspects, so he said to my mate, that he thought the Wi-Fi antenna may have touched something and shorted it out. So he was doing work in the Wi-Fi region of the board, and that's all we've said. So I think I might know what this is, and those of you who do a little bit of work on these machines probably screaming at the screen right now what you think it is as well. But we'll go over it and we'll show you the process and how we come to the conclusion that we do. So as you can see, dead as a doornail, orange light on the charger. Now, why is the orange light on the charger significant? Well, I'm going to show you something now. So if we just have a quick look at the computer screen now for a minute, the computer screen view, I am going to show you the schematic diagram for this motherboard. Now, this is one particular reason why I actually quite like working on Apple products, is because you can find the schematics. Now, unfortunately, these are not distributed by Apple by any means at all to unauthorized repairers. So, this document has found its way into my hands via Google. Unfortunately, because of that, I cannot possibly tell you where you can get these from. All I can say is if you spend 5 minutes on Google, you too will find them. But unfortunately, I can't tell you where you can get them from. Now, I do believe at some point in this document, in fact, yeah, I can see it there on the front, there is a clue as to where you can find these diagrams. So, unfortunately, if you ask me, if you message me or comment below where can I find them, unfortunately, I'm not at liberties to tell you. All I'll say is use Google, you will find it without too much searching. And the same goes for the board view. So what's the difference between a schematic and a board view? Well, a board view is a logically laid out map of the motherboard, so the components appear where they are. On a schematic diagram, it's a very logically laid out, so the layout on the paper isn't necessarily the same layout on the board. So you need the board view to find the components, and you need the schematics to tell you what those components are. Between the two, you've got a very good chance of navigating yourself successfully around the board and being able to pinpoint the issue, and everything else. So that's really quite nice. So yes, this is the schematic for this for this motherboard. So it's an 8203437B. Yes, it is indeed. You can see the document there, dated September 2013. So it is a mid 2013 model. It is a Core i5. So we're just going to remove the power supply from that MacBook now, because that's useless. I am going to strip it down now. I'm going to take the motherboard out, and we will go through what we need to do to get this thing working again. So bear with me in a second, boys and girls, and we'll get this board out, and I'll join you in a sec. Okay, then. So what we're going to do is we are going to take a look and see what's going on with our MacBook. So in order to do that, we actually have this board out now, and we're going to just connect the charger now just to verify what happens. So if we connect the charger, we can see we have a green light, and that turns to orange. We get absolutely no activity on the fan, but we do have a light on our charger. And the light on our charger is fairly significant, because the light on the charger is controlled by a circuit called the one-wire circuit. And the one-wire circuit actually utilizes components on our motherboard, an IC on our motherboard, to actually control the charging and everything else that the board does. So it's basically a power management IC. And if that's working, then we must have some activity on our board. It must be working to some degree. So we can't get the thing to start, and it appears dead, but there's obviously some sort of activity there. So what we're going to do is we are going to do what most people should do in these sort of circumstances, and we're going to check the power rails. And the main power rails on a MacBook are something called G3 hot rails. And if you basically think of a G3 hot rails as an oak tree, for example, right? Okay, and you've got the big, the big tree trunk in the middle, and then you've got the bigger branches running off, and then you've got all the little smaller tributary branches with all the leaves up. And essentially, the G3 hot rails are the big trunk, so that's what everything runs off. The G3 hot rails are sort of like the main power rails that supply all the other little components elsewhere in the system with your sort of power, if you like. And if one of those is missing, if one of those big branches is missing, then essentially all the little branches and the leaves connected to it are also missing. So if we've got a power rail missing, then we could have lots of things missing on our board, which means that it doesn't power up. So in order to do that, how the hell do you find your way around it? And what you do, if you have a look in the schematic, you can find a section called power rails. Now, most people put these on the front page, wouldn't they? No, not Apple. Not Apple. They put them right towards the back somewhere. So I'm just going to have a quick flick through this PDF, and they are all listed somewhere. Here we go. So what page? Power aliases. Here we go. So what page are we on? Page 62. Yeah, page 62 of 76. Seems a logically enough place to put everything like that, doesn't it? So as we can see here, these G3 hot always present rails. So these are the rails that should always be running no matter what the system is doing. So essentially you've usually got three states of power, S5, S3 and S0. And if you think of those as a pyramid, so S5 is when the computer is off. So what sort of things do you need when the computer's off? Well, how about, the charging circuit, the charging controller IC, power management, things like that. Because, of course, it's still desirable to charge your laptop whilst it's not being used. In S3, for example, that's when the computer's sleeping. So you don't need the graphics chip because you don't need the screen and things like that, but you do need memory and things like that. Because, of course, everything you're working on needs to be stored in memory so that when you open the lid and actually resume work, the computer knows where you were and can carry on from where you left off. S0 is everything that is in use when the computer is running, so that is usually absolutely everything that you can think of. But underlying, the foundation to those rails is the G3 hot, the basic main always-on power rails. And the thing is you can't get to the next state without having everything from the state previously. So you can't get to an S3 state without having everything from S5. You can't have everything in S0 without having everything from S3, because usually the S3 rails will gain power from S5 and use that to convert to other S3 rails, and so on and so forth for S0. And of course, if you don't have the always on, always present G3 hot rails, you can't have anything. So that's essentially what we've got here, and we've ended up where a lot of our board is actually not working properly. So if we have a look at this power aliases sheet here, we can see that's page 62 of this 76-page document. The first power rail that's actually listed there is PP Bus G3 Hot. And the machine actually uses PP Bus G3 Hot to generate a very, very lot of the power rails that it actually uses. It could be considered the main power rail, within the MacBook. And if we're missing that, then we are going to have a big problem. So what we need to do is we need to check and see just what that voltage should be, whether it's present, and if it is present, if it's actually doing what it should do, and if it's getting to the right places that we need it to get to. So that's what we're going to go and do now. So if we have a look at this G3 hot rail here, then on the screen. So I'm just going to zoom into it, and you can see here that PP bus G3 hot comes in, and the voltage there is 8.6 volts. So where we find PP bus G3 hot, we should find a voltage rail of 8.6 volts. If we don't, then we've got a problem there, and obviously we're going to need to find out what that problem is. So let's jump to the top of this document and see if we can find where PP bus G3 hot is generated. So this is sort of like the first step of troubleshooting. If a problem's here, great. If not, then we've got a bit of a hunt on our hands. So let's find PP bus G3 hot. That should be an underscore, not a dash. Oh, bloody hell. I can't type. Okay, so we see it here on the left-hand side, so that's where it's being an input for something. So it's already generated at that point, so we're not interested in that. And that's for Thunderbolt anyway. High side current sensing, again, that's not of interest to us. That's an input. G3 hot power supply 3.42. That's not really of interest to us either, but this actually is. So here we go. So this is where it's actually generated. If we take a look here, because we can see that it's actually an output from this line here, and it's going to system. So this is where PP bus G3 hot is actually generated, and this is of interest to us. So this actually comes from this ISL, this Intersil ISL 6259 QFM package, and this is denoted as U7100 on the motherboard. So on the schematic diagram, that is what we refer to the ISL 6259 as. It's basically a charging power management IC. And what it does is it takes voltage essentially. Oh, bloody hell, hang on. I hate Adobe Reader because bloody Zoom is awful. Right, so essentially what it does is it takes power from up here. So this is from like the charger and things like that, where the charger DC in, PP DC in, and the battery, which is further down to the right. And essentially it brings it into this IC. So what it does is it converts the 16 or 18 volts from the charger and converts it down to that 8.6 volts that we need to run the system. So in order to do that, what it does is it uses this Q7130 here, which is a dual N-channel MOSFET package. And essentially a MOSFET is a fancy switch. So what it does is it switches on and off, on and off, on and off, on and off very, very quickly. And it sort of gives it spikes. So you get sort of, 16 volts, 0, 16 volts, 0, 16 volts, 0. And the number of times and the length of time it spends at 0 actually averages out that voltage to a lower voltage. So what it does is it does that. So it switches on and off, and it gives you those spikes. Those are all collected in this inductor here at L7130, which smooths everything out. And coming out of there, you get a nice smooth voltage through that fuse there at F7140, and out to the system goes 8.6 volts at PP bus G3 hot. Or at least that's the theory. So because PP bus G3 hot is our first rail we're going to check, we need to make sure that we are actually getting PP bus G3 hot. So we are going to measure that at F7140. So this is usually where it shows up. So how the hell do you know where F7140 is? Well, this is where Open Board View comes in quite useful. So Open Board View has our board view schematic on here. So essentially what this is a roadmap of all the various bits and pieces and the connection points on our board as it's actually laid out in front of us. So we can actually find things really rather easily, and it's open source and it's really nice. So we're going to open the 8203437B board revision that we've got, and that's it now. So it's opened in the same layout as we have on the board in front of us on the table, so that's always nice. And what we're going to do is we're going to do a Control F, and we're going to find F7140. Because F7140 is where we can measure and see where PP bus G3 hot comes from. So if we just zoom out a little bit there, we can see that it's a fuse, and it's a fuse right underneath L7130. So if we have a look on our main board here, L7130 is our inductor, remember, where everything's smoothed out, that's here. And our fuse F7140 is here. And F7140, pin number 2, is where everything shows up. So we're just going to have a look under the microscope and see what that looks like. So, bear with me a moment, I'll try and get this in focus for you. So, this is our inductor here. This is L7130, and F7140 is just behind it. F7140 is there, and it does look a little bit brown on top. A little bit. So what we're going to do is we're going to connect our charger to our DCing board, and we're just going to see, and we're going to measure what L7140 gives us on pin 2. So that's L7140, and I'm just going to show you the multimeter in the other window. Just bear with me a sec while I try and get everything sort of in order. Alright, so F7140 is that little white fuse there. So if we have a look on the schematic, it says that F7140 is an 8 amp 24 volt fuse. It's a 1206 package. So what we're going to do is we're going to put one lead on ground. We're going to put our meter into volts DC. We're going to put our black probe on ground, and we're going to put our red probe on the left hand side, or pin 2 of that fuse there, and we're going to get a reading of 0.99.1, so it's just over 1 volt, very steadily growing. So that should be 8.6 volts, and it isn't. So on the other side of that fuse, pin 1, we can see we have our 8.59 volts. So we also know that, of course, coming out of L7130, out of that inductor, we should see 8.6 volts, 8.59, 8.6 volts, and we're on 8.58. So it's coming through the inductor absolutely fine. It's getting to the charger side of the fuse absolutely fine, but the system side of the fuse is buggered. And I don't know if you'll be able to see this, actually. I'll try and get you a view. I'm just going to disconnect the charger again. It's absolutely pointless that being that. You might not be able to see this. It might look a horrible mess. But you can see there, look down the side, there's a nice burn mark down the side of L7140, or F7140 even. So we're going to change that component. So we're going to get some hot air on it. So we're going to get some flux. Just going to move the old microscope out of the way. I'm getting back in the main view. And let's get that component swapped out. So hopefully then, well, it may not be our only problem, but it's certainly going to be one that isn't going to help us. So we're going to get that fuse swapped out. Now then, these things always look a hell of a lot bigger than they do on the camera than they actually do in real life. I mean, one of the big inspirations for my channel is a guy called Lewis Rossman, who works out of New York doing a lot of this Macbook repair stuff. And I'll tell you what, I've watched so many of his videos, and you see things on the microscope cameras and you think, oh, you know, it doesn't look too bad. But compared to a PlayStation bits look huge compared to some of these. It's amazing how small some of this shite is. Right, I'm going to have to go and unplug a few bits and pieces and move stuff about because I haven't got enough plug sockets. So of course we've remembered to remove power from the board before we touch it. So I would have liked to have done this under the microscope camera for you, but I haven't got enough plug sockets. And obviously the ring light on the microscope camera is an easy one to get rid of when we're dealing with a big fuse like this one. I'm trying not to block too much of your view with this. Okay. So that's F7140 got rid of. So now we need a nice new one to put in its place. Okay. Apply a dab more flux on that. I'm going to get hot air back. Okay, so we're just going to flow that into position. Ooh. Okay. It's always a pain trying to do that when you're trying to look down the viewfinder of a camera, but try not to block anybody's view. Or there you go. So our old fuse is looking decidedly sorry for itself, so we'll get rid of that. Okay, so that's that done. So what I'm going to do now is I'm going to get rid of the fume extraction because the noise does my bloody head in when we don't need it. Okay, and then I'm just going to go and change the plugs over again. So I'm going to plug the charger back in. I'm going to see what we get. So are we going to get anything? Are we going to get nothing at all? So let's zoom you back out. Okay, let's get rid of the multimeter. Get rid of the multimeter for now. Okay, let's bring you back. Let's bring this more in view. Okay, so we've got the fan there. So let's see what happens when we hit this charger now. Charge is connected, the fan is spinning. We've got a green light. And our fan has stopped. We've got an orange light. Here we go. So yeah, these airs do sometimes do a weird thing where they start, stop, start, stop, start, stop, and then start again. All very weird. I don't know why, but we can see there the fan's running. And there is a bit of an in-joke on this, as far as MacBooks go, that when the fan spins, we're done. Which costs a lot of old bollocks. But you'd be amazed how many people actually do believe that once that fan spins, that's it, we're fixed. So they don't believe in booting it up into OS X and make sure it doesn't kernel panic because something else is wrong. You know, a lot of places will call it fixed but can't get it into OS X, but they'll put Windows on it and of course it'll boot and then they'll go, you know, well, must be something else wrong with it. No, if you just do your job properly, then you'd be okay. So what we're going to do is we're just going to assemble that board now, and we're going to put it back into the chassis, and we'll boot it, and hopefully we'll get a working Mac. So bear with me, boys and girls, while I just go put that back in the chassis, and we'll see what we get. Right, okay, so we've got this thing back together, and time for the big switch on, so we're just going to connect the charger, and of course the thing automatically powers up. Hey, we have an Apple logo, and we're up. Of course, this thing has a nice SSD inside it. So that's it. We are done. And this is all working again. So we can hand it back, and we can save a few blushes from my mate's mate. But yeah, so that's that one. So as always, if you do have any questions or you found this useful, then just drop us some comments or a message or something like that. It's always much appreciated. If you like what we do on this channel, and hopefully we'll have a few more Apple stuff to come, then by all means, you know, hit that subscribe button. Like I say, if you found it useful, a like and everything is always much appreciated too. As is if you did find this useful and it helped you out in any way, if you do So have a couple of minutes there just to let the end ad play through. It always helps what we do on this channel. And as always, boys and girls, I will see you on the next one. So for me, it's ta-ta for now. So we know we don't have a short to ground there. So let's just see what we read across that resistor. We're getting nothing at all. So OL there, open line, basically means it's infinite resistance. So no connection at all between the 2 points. No resistance, no anything. We flip our probes around. And again, there's absolutely nothing there either. So it would appear that we have a problem with this resistor.